Do you or someone you know want to become a nurse and have to take the TEAS exam to get admitted to nursing school? Well, if you do, you've come to the right place because I'm Professor Capko and I'm going to help you with the math portion of the TEAS test. But first, I want to say I believe something great is going to happen for you today. And now back to the video. If you like test preps and guides that help you get ready to take professional exams, give this video a thumbs up. That way I can know that we need to make some more of these videos. All right, the good news is that I'm preparing a course on how to pass the TEAS test math portion. Now, if you're unfamiliar with it, the TEAS test is the test of essential academic skills, and many nursing schools require you to take that test and do well on it before you can get into nursing school. So I'm going to help you get in there, but first let's go ahead and go over one of these questions, and then I'm going to invite you to go to my website, askprofessorcapco.com, and sign up for my free email newsletter. That way I can email you when the course is ready. I'm putting it together now at the time of this video, and it will be ready very soon. So you want to be the first to know when that course is ready so you can take it and be prepared for the TEAS test. And I also ask that you subscribe to this channel and click that notification bell so you never miss a video. Thank you. All right, let's look at this example question. An elevator has a capacity of 2,500 pounds. A moving company is transporting a 85-inch television that weighs 150 pounds, along with desktop computers which weigh 35 pounds each, using the elevator. Which algebraic expression below represents the limit of the desktop computers that can be transported with the television on the elevator? And you can see there's A through D, some choices of algebraic expressions, and you're going to have to choose which one is the best one. And so let's take a look at this and break it down. So we know that we're talking about the capacity of the elevator. The capacity in this case is in terms of weight, 2,500 pounds. It could be discussing capacity in size, such as volume, like number of cubic feet, something along those lines. But in this case, the capacity we're discussing is the weight. So we're going to be concerned with the weight of the items that we're carrying on the elevator. Here it tells us there's an 85-inch television that weighs 150 pounds. We are not concerned for this problem with the size of the television. If you don't recall, the two little marks up there indicate inches. Inches. If there was just one, it would be feet. But there's two, so that indicates inches, which is telling us that's the size of the TV. We're not concerned with the size of it. We're concerned with the weight. So we have a 150-pound television, and we're going to carry it with, which means we're going to add to it computers weighing 35 pounds each. So we know we have at least 150 pounds because we're carrying it with the television. We don't know how many computers that we can carry, but we know the maximum is 2,500 pounds. So let's see how we can do this as a formula. If we don't know the number of computers, we can represent that with a variable. So we would multiply the weight times the number of computers, but we don't know that number because that's what we would be solving for. And in this case, we don't know it, so it's going to be a variable. Oftentimes we use an x as our variable, which is perfectly fine. But if you look at the answers, and I always recommend that you take a look at the answers, you can see that they are using the variable c. And that tells me that they want C to represent the number of computers. So that's an unknown. That's what we're trying to figure out. And in fact, this problem, we don't have to figure it out. All we need to do is set up the problem. So C is the variable we're going to use. So if we want to know how many computers we could carry and what the weight would be, we would first start out with 35 pounds, so 35, and we'd multiply it by C, which is the number of computers. If you multiply the weight times the number, the weight each one is 35 times the number of computers, that's going to give you the total weight of that number of computers. We also need to add to that the weight of the television. The television, we're told, is 150 pounds. We know there's only one, so we don't have to multiply it by anything because we're, in theory, multiplying it by 1, so we can not worry about that part. We know our maximum capacity is 2,500 pounds, so we don't want it to equal that necessarily. It could, but we could also have an amount less than that. We just don't want to have an amount larger than that. So we're going to have a inequality, and we're going to do it this way. Remember that my recommendation is the inequality, we think of it as an alligator mouth, and the alligator wants to eat the larger meal. So in this case, this is telling us that this here is less than this. This is larger than that. And we want this to be our maximum, so we can also have an equal. So we do the equal sign with a line underneath. If it didn't have this line underneath, it would just be this is less than that, but we've got this is less than that, but or it could be equal to it because it's okay to carry exactly 2,500 pounds. So we've set up our formula here, and we can look to see if there's anything like that. Here, if we notice, this one uses the 85 inches, which is the size, not the weight, so we can eliminate that one right away. In this one, we're adding the weight of the TV to the weight of one computer, and then we're multiplying it all by C. That would be incorrect. We're only bringing one television, so we don't want to multiply the weight of the television by C, so we can eliminate that one. And this one, we're taking the 2,500 pounds, or subtracting the weight of the television, and that's going to equal the 35C. We would not want it to, number one, just equal. We'd want it to be less than, so we don't want this one either. So if you could see, B is set up exactly the right way. It's exactly what we came up with, so B is the correct answer. Hopefully you found this helpful, and again, like I said, if you have, sign up for my email newsletter, and I'll let you know when that TEAS course is ready. Until next time, keep your grade alive and subscribe. Thank you.